When we talk about single replacement reactions and how one element takes the spot of another element to form a new compound, one thing we have to keep in mind is the question of, will that element even want to take its spot? Will the reaction even happen? And there is a way we can predict whether or not the reaction takes place. For example, I like to use the analogy of me changing shirts to represent single replacement reactions. Now, do I just randomly change my clothes? Do I just switch shirts because there's a different one available? The answer is no. I have to have a reason to change shirts. There has to be one that is more comfortable or better than the other one. So if I'm comparing shirts and one is more comfortable and better than the other one, then I will wear the one that's the best. If it turns out that I'm already wearing the more comfortable one, then I won't change. But if the more comfortable one is not being worn by me, then I will switch shirts. So the same thing happens in chemistry. Let's take a look at this reaction. We have lithium and zinc chloride. So this looks like the beginning of a single replacement reaction. We have lithium all by itself as a pure element, and then we are trying to react it with zinc chloride. Now, because the lithium is a metal, it will form a cation when it becomes an ion, which means that it will replace the zinc or the cation in that ionic compound. So will this reaction go? Well, just like I would compare my shirts and pick which one is the best and then possibly replace it if I wasn't wearing it, that's what we are going to do with these two elements, the lithium and the zinc. So here's a list of several metals, and this list is called the activity series of metals. Now, there's an activity series of nonmetals too, but I'm not going to show you that in this video. So at the top of this list, we have the most active metals, and at the bottom of this list, we have the least active metals. So we are going to compare the lithium and the zinc. So I'm going to highlight the lithium and highlight the zinc. And the lithium will replace the zinc. And the reason for this is because a more active element will replace a less active element. So let's write out the products for this reaction. If lithium is taking the place of zinc, then zinc will be all by itself. And that will give us lithium chloride as our ionic compound. Now remember, lithium has a positive 1 charge when it forms an ion, and chloride has a negative 1 charge when it forms an ion. So if you put the two together, it creates lithium chloride, 1-to-1 ratio in that ionic compound. All right, so always remember that a more active element, so one higher up when you're comparing, will replace a less active element in a compound, or one that is lower on this list. They could be next to each other, but as long as one is higher than the other one, the higher one will always replace the lower one. Now the reason for this is because chemistry likes to move towards stability. So the products of this reaction are more stable than the reactants, and that is because zinc is more stable. It's a less reactive element, and it's by itself. Lithium, when lithium is by itself, it is a much more reactive element. So the lithium doesn't want to be alone compared to the zinc. The zinc is totally fine being alone because it's less reactive. So think back to my shirt analogy. I don't just change shirts randomly. I have two shirts that I'm comparing, one that is better than the other one. If the better one is not being worn by me, I will switch. If I'm already wearing the better one, then I'm not going to do anything or change anything. So then no reaction will take place. So I want to show you these two very similar sets of reactants. We have gold and zinc chloride, or we have zinc and gold chloride. And I want you to think about which of these reactions will take place. All right, let's go through it. So the answer is that the second one will take place. The first one will create no reaction. That gold and the zinc chloride will just sit there in solution and not do anything. Here's why. We have zinc and we have gold. Zinc is more active than gold. So that means that zinc will replace gold. Zinc will want to be in that ionic compound more than gold. Gold is fine being by itself. Well, in the first reaction, gold already is by itself and zinc already is in an ionic compound. So if they're already more stable in that configuration, then no reaction will take place. Let's look at the second one. Zinc is higher up on that activity series, more reactive, so it will take the place of gold. That means that gold will end up all by itself, which is totally fine because gold likes being alone. It's very unreactive. And then zinc will join up with the chloride and create this compound, and we're going to create zinc chloride. We have more stable products in the second reaction. So the second reaction will take place. The first one will just sit there. Okay, so let's try some practice problems. I want you to pause the video and attempt these problems on your own. Show all of your work, and that way when we go through it, if you made any mistakes, you can diagnose your error. So the question is will magnesium react with hydrochloric acid? If so, write out the equation and balance it. So we are looking at magnesium and hydrochloric acid. Now magnesium is a metal, which means that if it forms an ion, it will form a positive ion, which means that it will replace the hydrogen portion of the ionic compound, that cation portion of the ionic compound. So we are going to be comparing magnesium and hydrogen. Which one is more active? So we have magnesium and hydrogen. Magnesium is on top and hydrogen is on the bottom. So magnesium is more active than hydrogen, which means that hydrogen is okay being alone. It's not as reactive. It's fine being alone, which means that the magnesium will take the place of the hydrogen. So once the hydrogen is kicked out, hydrogen's all by itself. But keep in mind that hydrogen is diatomic. So it's never really by itself when we write it in a chemical equation. We have to include the subscript 2 to show that it's diatomic. Now let's write our new compound. Magnesium is now bonding with chloride. So magnesium has now formed that ion, a positive 2 charge. Chloride is a negative 1 charge. And when you combine the two, you get MgCl2. So all of our compounds in this reaction are written correctly. All the diatomic elements are written with 2's. The non-diatomic elements don't have the 2's. All of our ionic compounds are written so they are in neutral form. And the last thing we need to do is balance this equation using coefficients. So I'm going to put a 2 in front of the hydrochloric acid because I have 2 hydrogens and 2 chlorides on the right side of this. That means that every other reactant and product will get a 1 in front of it. Now, you don't have to draw the 1s, but I like to represent them as 1s because I think it helps us see ratios and see the quantities of each product and reactant that we have. Okay, now why don't you try the second one? Will iron react with sodium chloride? If so, write out the equation and balance it. All right, so I'm gonna highlight sodium and I'm gonna highlight iron on this list. These are both metals. They will both form cations if they're in an ionic compound. Now let's determine if this reaction will go. So sodium is more active or more reactive than iron, which means that iron's okay being by itself and sodium really wants to be bound with something else. It's much more stable if sodium is with something and iron is fine being alone. So there's more stability if we're comparing the two that iron is by itself. And guess what? Iron is already by itself. So it's not going to kick out the more reactive element. It's not going to kick out the sodium. So these reactants will not produce a reaction. So in this video, I showed you that not all single replacement reactions run. There has to be some driving force to get those elements to switch spots.